Hey guys, last time we talked about all those rotating frames and Coriolis forces, etc. Today we will see about angular motion and its relationship to linear motion. What's angular velocity and what does its relationship v equals r omega mean? Let's go with the usual string and stone example, where the stone has a clockwise angular velocity. This omega is responsible for the stone's circular motion. It's denoted either in rotations per second or in radians per second. The first one can be easily visualized. It's the number of times the stone crosses a fixed point in the circle, or just the number of times it goes around the center. But a radian per second is the SI unit, as it's much reliable. It gives a section of the arc covered by the stone within that small interval of time. More simply, it's just an angle in terms of radian. Both the units differ by a factor of 2 pi. 2 pi indicates a full rotation in radians, so the number of rotations n translates to 2 pi n radians. Now let's substitute that in a relation. We get the circumference of the circle per second. That's the difference. While omega uses the angle covered by the stone, v makes use of the distance covered along the circumference of the circular path. The direction of this velocity vector at a point is the tangent drawn to the circle at that point, and that too gives the direction only at that instant of time. That's why we say there is a radial acceleration inverse when following a circular path. Now let's see what the angular acceleration alpha says. It's related to the tangential acceleration as a equals r alpha. The very same thing. Going with the same example, this alpha is nothing but the rate of change of the angular velocity. If there is no change within that interval of time, then alpha is 0 for sure. The direction of this tangential acceleration is the same tangent, as it indicates how the tangential v changes with time. Let's visualize that now. Here the stone is circling with some constant angular velocity, so there is a radial acceleration inwards towards the center, but no tangential acceleration, which you can see by the arrow with a constant length but with an ever-changing direction. Now let's start changing the angular velocity continuously. As you can see, the length of the arrow increases as some tangential acceleration is given to the system. Well, it's a velocity vector. The length is magnitude while the arrow gives its direction. That change represents the birth of alpha. Thank you.